Hello students, this class I'm not able to show on the whiteboard, so I'm showing this on a paper. If you are not able to see what I am writing, you can leave a comment about it. So now let us see this problem based on Euclidean lemma from the chapter Real Numbers. This problem has taken from the NCERT textbook exercise 1.1, question number 4. The question is, show that the square of any positive integer is of the form 3q or 3q plus 1 for some integer m. There is a hint is given in the question that we can take let x be any positive integer and it is of the form 3q plus 1 or 3q plus 2. So we are using that hint and we are continuing our answer. Let x be any positive integer, then it is in the form 3q or 3q plus 1 or 3q plus 2. So we have here three forms of a positive integer, 3q plus 1 and 3q plus 2. When we square these forms, we should bring the square of this positive integer in the form of 3m or 3m plus 1. So we have three values, so we need three cases. Now case 1, we have to take this x positive integer as a 3q. Now we are going to square on both sides of it. So x square, also we can square the right side value, that is 3q whole square. Now when we square this one, we get 3 square is 9, q square is, we can write q square. This further we can write as 3, we can take it common outside as 3 into 3. 9 we can write as 3 into 3. So 1 3 we are taking outside 3 q square. So x square is equal to, instead of this we are substituting m, where m is equal to 3q square, like our previous question. Now let us take another case 2. This time we are taking another value, that is x is equal to 3q plus 1. I'm squaring on both sides. X square is equal to 3q plus 1 whole square. Now a plus b whole square formula we have to use, that x square is equal to 3q the whole square plus 2 into 3q plus 1, that is 2ab plus b square value 1 square. When you square this one, we get 9q square plus 6q plus 1. From these two we can take 9 common outside. 3 we can take common outside. So I'll write here, so x square is equal to, when you take from these two 3 common outside, 3 3s are 9, so 3q square, 2 3s are 6, isn't it? So we can take 2 inside plus 1. So we can substitute, instead of this we can substitute m plus 1, where so x square is equal to 3q plus 3m plus 1, where m is equal to 3q square plus 2q. So So this is one integer actually. That integer we are substituting as m. So m is equal to 3q square plus 2m. So we are taking third case now. Third case. So case 3. So we are taking case 3. So we are taking that x is equal to 3q plus 2. So x square is equal to 3q plus 2 whole square, which is equal to, we can write a plus b whole square, 3q square plus 2 into 3q plus 2 plus 2 square. So we get 9q square plus, when you multiply these two, sorry, this into, when you multiply everything, we get 12q plus 4. This 4 further we have to split, so we get 3 from it, so we can take common outside, so we can bring this format. Why we are splitting? To bring this format, we are splitting 4 as 3 plus 1. 9q square plus 12q plus 3 plus 1. So from these 3 we can take 3 outside, so we can take 3 outside from it. So 3q square plus 4 threes are 12, right? So we can take 4q here. So 4 threes are 12 plus, from here 1. 1 3 is 3 plus 1. So the x square is equal to this entire value, we can take it as m. 3m plus 1, where m is equal to 3q square plus 4q plus 1. So now you can see that the case 1 we brought the format of 3m, in case 2 we brought the format of 3m plus 1, and case 3 we brought the format of 3m plus 1. So we came to answer. Finally we have to write hence the square of any positive integer is of the form 3m and or 3m plus 1. Students, if you did not understand, you can play back once again the video and you can watch it again. Hope you understood. Thank you for watching.